three young galaxies are falling into a massive gravitational sink and colliding with each other. Stars form like beacons, and a gigantic red quasar blazes at the center. When researchers first made this ancient structure visible using the James Webb Telescope, it was as if they were witnessing the birth of the first solid structures in the universe. The quasar SDSS J16520 2.64 plus 172,852.3 appears like a cosmic inferno, forming order and new matter out of chaos and destruction. With this discovery, astronomers are once again entering uncharted territory. The red quasar in the JWST's focus is a living, seething, violent galactic center, and a true cosmic fossil. The quasar, its host galaxy, and the companion galaxies are very likely part of a much larger, as yet not understood event in which dark matter halos are pulling the strings in the background. For the first time, we are witnessing the powerful forces of the cosmic web gathering the first galaxy clusters into a single new galaxy. The collision of three galaxies in a common center is an astronomical treat of the highest order. The images reveal precise details about the forces that shaped the first galaxies and how loose star clusters evolved into beautiful galaxies in dense gas clouds. What initially appeared to be just a dot in the sky is now very likely rewriting the history of the early universe. The red quasar named SDSS J16520 2.64 plus 172,852.3 is more than 11.5 billion light-years away from us. The light from this cosmic giant began its journey at a time when the universe was just 2 billion years old. Quasars are the brightest objects in the universe. They shine so brightly that they can outshine their entire galactic surroundings. They are powered by supermassive black holes that devour the gas and all available matter in their vicinity with unimaginable velocity. As matter flows into the black hole, friction is created that releases enormous amounts of energy in the form of radiation, and this is precisely what powers a quasar. Red quasars can appear like truly hellish spectacles, and when we consider the presence of an extremely voracious black hole in the immediate vicinity of the glow, the scene becomes downright diabolical. However, the red light is not authentic, but is caused by the long journey of light to us. During its journey through space and time, the light is shifted into the red spectrum by the stretching of the expanding universe. In astronomy, red is always synonymous with distant and old. Red quasars, like SDSS J16520 2.64 plus 172,852.3, are shrouded in thick clouds of dust and gas that absorb their radiation and make them appear reddish. For a long time, these objects were invisible to astronomers. Dust and gas concealed them, so well that we couldn't see them with the old telescope technologies. The red quasar eats and creates stars. SDSS J16520 2.64 plus 172,852.3 is in a phase of maximum activity. The central black hole is growing rapidly by literally sucking in its surroundings. Scientists refer to this process of extreme mass destruction as accretion-induced mass growth. At the same time, the quasar blows violent radiation winds into its surroundings, stimulating star formation in the galaxies involved. This monster destroys and creates at the same time. It is much more than just a gigantic red quasar. The red beacon in the young universe plays the leading role in a cosmic spectacle that is not seen every day. The red giant glow is the center of three galaxies. The trio of young galaxies is attracted, compressed, and reshaped by the gravity of the black hole at its center. These three are certainly not just random neighbors, but part of a close interacting galaxy system that merged into a single massive galaxy cluster more than 11 billion years ago through the power of the quasar. Red quasars are now considered transitional objects and a link between a dust-shrouded phase of galaxy evolution and the later phase in which the quasar becomes clearly visible. These powerful and strange objects provide clues about how active galactic nuclei evolve, how black holes grow, and how these processes influence star formation, making them an important key to galactic evolution. The trio of galaxies is the focus of particular scientific interest. Data from the James Webb Telescope impressively shows how the three galaxies are moving around the quasar, each at its own speed and each in a different phase of merging. Despite their common center, different forces are at work in each galaxy brought together by the process of merging. Using spectral analysis, researchers were able to determine not only the positions, but also the directions of movement of these galaxies with fascinating accuracy for the first time. To do this, they used the emission light from ionized oxygen. Red-shifted areas indicate that parts of the system are moving away from us, while blue-shifted areas show approaches. All these movements combine to form a complex picture that reveals more about the forces at work and the connections within the galaxies, their surroundings, and the background. The collision and merger of galaxies in the universe is not just a random galactic dance. Processes like these are perfectly organized and synchronized. The more researchers learn about the forces and systems at work, the closer they come to understanding the blueprint of creation. In this trio of young galaxies, we're dealing with a young core region from which a galaxy cluster will form as cosmic evolution progresses. The JWST images show us the first known protocluster, and thus one of the oldest formative structures in the universe. This primordial structure has probably shaped and influenced so many areas in the further development of the universe that it can be seen as a kind of primordial mother. The merging of several dark matter halos with a quasar at its heart was very likely one of the strongest gravitational and formative events in the early universe. The cluster that emerged from the protocluster certainly still exists somewhere in the universe today. It's likely that the formation has since grown into a gigantic collection of thousands of galaxies. Dark matter halo and the role of AGN feedback. This red spot, which at first glance appears unremarkable, is actually a cosmic creator of the highest order. The red quasar, its enormous luminosity, and the massive gas outflows known as quasar winds are the most active parts of this dance. However, the dynamics and actions of this spot go much further. The quasar actively shapes its environment through the winds. These winds can even heat, compress, or disperse the gas in neighboring galaxies, which also regulates star formation there. Scientists call this process, which is considered a crucial mechanism for the structuring of galaxy clusters, AGN feedback. In this unique constellation, the quasar acts like a cosmic conductor, helping to determine the movement of its companion galaxies and shaping the entire galactic environment. We owe the discovery of such systems to the revolutionary resolution and spectral analysis capabilities of the James Webb Telescope. The images are much more than just a curious glimpse into the past. The findings provide us with fundamental knowledge about the basic mechanisms that will help us better predict the future of the universe. But the really exciting thing is not even the bright red quasar itself. Something far more powerful than a quasar must be holding this chaotic, swirling system together. The answer lies not in what we see, but in what we don't see: the dark matter halos. The invisible structures hidden behind the light show. Astrophysicists suspect that beneath the glowing surface of this galactic trio lie several dark matter halos. Enormous invisible shells made of a matter that does not emit radiation, but exerts incredible gravitational pull. These halos are probably the secret forces behind visible structures throughout the universe. In simulations and models of cosmic evolution, dark matter halos are the places where galaxies can form in the first place. You can imagine a halo as an invisible gravitational landscape in whose valleys gas first accumulates, then condenses, and ultimately forms stars and galaxies. Without dark matter, there would probably be neither galaxies nor quasars. In the case of the quasar trio, researchers assume that there are at least 2 or 3 dark matter halos with masses in the range of 10 to the power of 13 solar masses. That's about the mass of a massive galaxy cluster. These halos merge with each other just like their visible galaxies. Their collision creates a strong central gravitational potential, a gravitational node where the quasar sits and grows. The quasar itself is not just a passenger in one of these halos, but is probably the result of a particularly dense halo region. So much matter was able to accumulate there that a supermassive black hole was formed, which subsequently became a luminous quasar through accretion. The massive movements of the neighboring galaxies indicate that these halos are hurtling toward each other at high speeds, turning the entire area into a kind of cosmic cauldron. This proto-galaxy cluster, with all its dynamics and peculiarities, could provide a breakthrough in the study of dark matter in the near future. Dark matter remains one of the greatest mysteries of modern physics. It's estimated to make up 85% of all matter in the universe, but has never been directly detected. Only its gravitational effects reveal its existence. In this case, the interplay of forces is particularly exciting. The high-density, kinetic energy, and merger processes of the quasar trio are already revealing many new facts about the interaction between dark and visible matter. The more data we have, the more confident we can be in our understanding of the nature of this invisible matter. What did the universe look like before galaxies like our Milky Way were born? For a long time, researchers thought that they could answer the question of what the universe looked like before the birth of the first stars and galaxies with certainty. But since the first images from JWST, doubts about the old theories have been growing. Now, the merging trio of galaxies could reveal what really happened in the era barely 2 billion years after the supposed Big Bang. What Webb is showing us here is a fundamental key to understanding the cosmos. Proto-galaxies are the first precursors of fully formed galaxies. They consisted mainly of the light elements hydrogen and helium, probably containing few or no stars. Instead, they were dominated by huge clouds of gas, often interspersed with cold dark matter, which slowly collapsed and formed stars. These early objects were extremely faint, mostly diffuse, and difficult to detect. Around the red quasar, the proto-galaxy was probably exposed to conditions quite different from those in other early galaxies. The combination of a gigantic black hole, a glowing quasar, and the merger of 3 very different young galaxies into a new galaxy may have been a dramatic accelerator of development. Presumably, these 3 star clusters were more chaotic, gas-rich, and unstable objects before they collided, thanks to the gravitational pull of the black hole, and were able to assume a higher state of order due to the immense forces at work. The powerful quasar also drove the star formation rate up dramatically, while dark matter halos in the background created ever more momentum, power, and change through a process known as positive feedback. James Webb shows us that proto-galaxies often appeared in groups in the early universe, most likely brought together by the immense power of the underlying dark matter halo. As true gravitational traps, the halos were able to collect many gas clouds at the same time, compress them extremely, and collapse into star-forming regions. You can imagine this as a gravitational sink in the space-time fabric. Several proto-galaxies fall into the same pit, collide, exchange material, and begin to form the first complex structures of the young universe. This means that halos were most likely present long before the first visible particles of matter. They may have existed shortly after the Big Bang, at least in a primitive form. How dark matter and visible matter actually came into being is one of the great mysteries of science. The moment when the first basic forms of matter were formed was also the moment when our lives became possible. Click subscribe now and be part of every new video.